All right, so now we're going to look at the probability of one event happening and another thing happening. The probability of this and that. So now both of them have to happen. When we did or meant only one of them had to happen, but with and, you have to have both of them happening. If you don't have both of them happening, then the number is not going to be included. So the first thing we're going to do is we're going to complete the contingency table. It's not on paper, we're doing it digitally, but still it's basically on paper. So in this box, this is box A, we're going to put the number 44. So we'll put a 44 here. B is 16, so that's going to go right here. 16, we'll put that right here. C is 11, so that's going to go right here. So we'll put an 11. D is 30, and so we'll put a 30 here. Now we'll complete the rest of the table. If we add up 44 plus 11, that goes right here. 44 plus 11, that's 55. 16 plus 30, that's 46. Sideways, 44 plus 16, that's 60. And 30 plus 11, that's 41. And 60 plus 41, that's 101. And 55 plus 46 is also 101. So our total is 101. And we need this number again. When we do the probability of one event and the other event, it's out of all of them. So it's going to be out of 101. Okay? So the probability of X and Y occurring, both of them happening, is going to be equal to something out of 101. Out of the total of 101. So how many of them out of 101 include both X and Y? Well, let's look at this 30. This 30 right here, it includes X complement and it includes Y complement. Well, that's not X or Y. It's not either of them. So we're definitely leaving that one out. Okay, so this one is out. Okay, leaving this one out. How about 16? 16 does include Y, but it does not include X. It includes X complement. So since it's not both X and Y, we're going to leave 16 out. How about 11? 11 includes X, but it does not include Y. It includes Y complement. So that one's out. The only one that includes both X and Y is 44. And so that's the only one that we're going to do. We're going to do 44 out of 101. And now we go to the calculator and do 44 out of 101, and our answer is 0.45. And this 6 is going to round this 5 up to a 6, so it's going to be 0.436. So the answer is going to be 0.436, and that is our final answer, 0.436. Okay? Let's do one more example with a tree diagram. All right, here's a tree diagram, and just like the last video, we have the branches. The total is broken up into male and female. So this number is all of the males, and this number is all of the females. Then we're going to break up the males into college and no college. So A is the males with college, and B is the males with no college. C is the females with college, and D is the females with no college. So that's 4 different categories. A up here says 24, so A is 24. B is 32, so put a 32 here. C is 38, so we'll put a 38. And D is 22, so we'll put a 22. Okay, so 24 here has a branch that says college, we'll put a C. 32 is at the end of a branch that is no college, that's NC. Okay. The 38 is at the end of a branch that says college, and the 22 is at the end of a branch that says no college. Now if we add up 24 plus 32, that's 56, so we'll put that here. Now if it was on here, that would go right here, so this one would be 56, okay, but I'm redrawing it over here. And then here, 38 plus 22 is 60, so that'll be 60. Now, 56 is at the end of a branch that says male, and 60 is at the end of a branch that says female. See that? Now, for this number, the total, we will add up 56 plus 60, and that gives us 116. So the total is 116, and we want to know what is the probability of male and no college. So the probability of male and no college, okay? Well, this one right here, 22, that's no college, but it's female. So this 22 is female and no college. We don't want that. This 38, it's college and female, but the fact that it's not no college, it's college, so we don't want that. This 24 is college, so we don't want that either, even though it's male. This number is male and college, not no college. But this 32, it's no college and it's also male. It comes from the male branch and the no college branch, so that's what we want. We want male branch and no college branch, and it has to be both of them. And this is the only one that's both of them. Now the 32 goes in the numerator, and the denominator is the total, 116. 116. And so we'll get a calculator, 32 divided by 116. 32 divided by 116. And we get 0.2758. This 8 is going to make the 5 a 6. So this is going to be 0.276. So the answer is 0.276. That's what we're going to put in this box right here. We're going to put in 0.276. And that's it. That's how we do probabilities that have an and in them.